Okay, today we're going to be solving quadratic equations, and before we do this we need to talk about what a quadratic equation is and what the solutions will look like. So I've got three facts here that is really worth remembering for any quadratic you're solving. So a quadratic equation contains a squared term. That's what the word quadratic means. So usually x squared, but the highest power will be squared. If there was a cubed or a power 4, then it wouldn't be a quadratic equation. If there isn't a squared in it, if there's no powers at all, then it's a linear equation. So a quadratic equation is when the squared is the highest power. Before we can solve a quadratic equation, it must be equal to 0. I'll explain why this is the case as we go along, but it's very, very important to remember that before we solve it, it must be equal to 0. And the third thing, a quadratic equation can have 0, 1 or 2 solutions. So there can be no answers, one answer or two answers, usually 2. And that's quite unusual. It's probably the first time we've come across equations that have 2 solutions and they're both correct. It isn't that one's better than the other, they're both correct. So we're going to solve these quadratic equations by factorizing. You do need to know how to factorize quadratic expressions before attempting this. So that's something you may need to practice. So I've got 4 examples to start with. The first one, x squared plus 5x plus 6 equals 0. So it's equal to 0, so that's okay, and its highest power is a squared, so it's a quadratic equation. And we're going to solve this by factorizing. So I need to factorize this quadratic expression. When you're factorizing a quadratic expression like this, it goes into double brackets. And this is the thing you have to be able to do. We'll just have a quick recap. We've got an x at the start of the brackets because those will multiply to make x squared when you expand the brackets. And these two constants here must multiply to make 6, and they must add together to make 5. So it's going to be x plus 3, x plus 2. If you're not sure how to do that, you might have to go back and practice. The reason your quadratic must be equal to 0 becomes important now, because you've got this bracket multiplied by this bracket, which equals 0. When you multiply two numbers together and you get an answer of 0, one of them must be 0. So we can say on the next line of work in here that either this bracket, x plus 3 equals 0, or this bracket, x plus 2 equals 0. And then once we've realized this stage, the final stage isn't too tricky. If x plus 3 equals 0, x must be negative 3, or if x plus 2 equals 0, to make this true, x must be negative 2. So those are your two solutions. Got a second example here. This one looks slightly different. In the first example, we had a quadratic term, a linear term and a constant. In this one we have no constant part, but it's still a quadratic because x squared is the highest power. And we still look to factorize it. Because this is just two terms without a constant, we can just factorize it with a common factor. So we take out the common factor of x and we're left with x bracket x plus 3 equals 0. It still has to be equal to 0. And now I've got this x multiplied by this bracket gives me 0. So on next line, I've got x equals 0 or x plus 3 equals 0. This part is already solved, x equals 0. And to make this side true, it must be x equals negative 3. That's my other solution. So I've got two solutions like I did with the first one. This third one is similar to the first one, and this is the most common type you'll see with a quadratic term, a linear term, and the constant. So I need to factorize this into double brackets. This time they need to multiply to make positive 12 and add to make negative 7. Very important that you don't get your signs mixed up here. So that's going to be x minus 3 and x minus 4, because negative 3 times negative 4 will give you positive 12, but they will add to make negative 7. So this time I've got x minus 3 equals 0, or x minus 4 equals 0. So if this is the case, x equals 3, and if this is the case, x equals 4. And I'm sure you're seeing lots of patterns taking place here. The final one I've got is very similar to the second one. There's no constant term, so I'm just going to factorize by using a common factor. The highest common factor here is 2x, so I can take a 2x outside the bracket, and I'm left with x plus 1 equals 0. And so I've got 2x equals 0, or x plus 1 equals 0. If 2x equals 0, then x also must be 0. If x plus 1 equals 0, x equals negative 1. If you want to check any of these solutions, you can substitute them back into the original and prove that when you substitute these in here, you get back to 0. And it will work with both solutions. My final example is x squared plus x equals 20. Now it's a quadratic equation because squared is the highest power, but it's not equal to 0. So I can't start to factorize it yet. First thing I need to do is need to make it equal to 0. I'm going to make it equal to 0 by taking 20 away from both sides. This now makes it equal to 0, and I can proceed as normal. So I'm going to factorize into double brackets. So I'm looking for a pair of numbers that multiplies to make negative 20, but adds to make positive 1, because there's 1x there. So that's going to be positive 5 and negative 4. So this multiplied by this bracket equals 0. So I get the same pattern now. X plus 5 equals 0, or x minus 4 equals 0. For this part here, that will be x equals negative 5. And for this part, x equals positive 4. So once again, we have two solutions.